Right, so here we go. We're going to do kind of the same thing, but instead of them being ordered pairs, they're equations. So let's just review the same identities that you know. Guys, remember x that you used on your warm-up is r cosine theta. You know that. We just did that on the warm-up. Y is r sine theta. R, I'm going to write this kind of squished together. Watch. R is, you know, the square root of x squared plus y squared. But we don't really want roots on equations. So fit this also. R squared equals x squared plus y squared. And then remember, tangent is still y over x. All right, so here's what's happening. We're going to convert polar equations to rectangular equations, and rectangular form is like, what if I wanted to plot this on the inspire? That's what we're converting this to. So you're going to have the letters x and y, and they need to be on one side of the equal sign. And then down here, we're going to take what it would look like on an inspire and write it in polar form. But guys, down here, like it could be r. It could be r squared. You might have just plain theta equaling something. It could be a combo. But all of this stuff still has to be on one side. So there's more than one plan of attack here at the bottom. The top is pretty much just x and y. There's only one way you can do it. All right, so here's how this is going to work. You're going to look at your equations, and you're going to try to rewrite it based on this substitution here. If you notice, I have a plane r, and I know plane r is x squared plus y squared. Well, that's not even anything over here. And I don't want a root. So that's why we also wrote this. Now this r is not squared. So we're going to focus on squaring this r. And there's two ways we can square it. It's an equation. We can multiply both sides by the letter r, or we can square both sides. And I don't want to square both sides because that would turn into sine squared, and we don't have any sine squared happening here. So let's multiply both sides by r and then take a look at what happens next. All right, so we're going to have r squared. All right, so this is 4 times sine theta times r. Y'all put the r after 4 because it looks weird next to the theta symbol. So write it like this. Write the r in front of sine squared. And y'all, we're ready to substitute. Remember, r squared is x squared plus y squared. So that's going to be this, x squared plus y squared. Oops, I'm zoomed out too much. That's what that means. And then look, ignore the 4, but look, r sine theta, r sine theta. These last 3 pieces is the letter y. So this is going to be 4y. And then that's it. We're going to move the 4y over because remember, all of your x's have to be on one side and all of your y's have to be on the same side. So this is going to equal 0. And that's okay. I mean, it could equal a number if we had a number. It doesn't have to equal 0 every time. You just have to make sure all your letters are on one side of the equal sign. That's all that means. All right, let me go ahead and look at problem number 2. So for problem number 2, we have r equals 4. All right, So again, we have plane R, but it's so much easier to make it R squared. So again, if I did it like this problem where I multiply both sides by R, the left side would be R squared, but then the right side would be 4R, and I'd get stuck on that. So let's square both sides. So we're going to have R squared, and I'm not going to get stuck over here because that's just a 16, not a plane R. So what is R squared again? It's x squared plus y squared. So this is going to be x squared plus y squared equals 16. That's it. All right, let's take a look at the next one. So for the next one, we have R equals 4 cosecant theta. Y'all, there is no cosecant. There's no reciprocals. So let's get rid of the reciprocal and write the fraction form. So we're going to write 1 over cosine, or I'm sorry, 1 over sine theta on this side. So R is going to equal 1 times 1 over sine theta. All right, so y'all, just like there's no cosecants, there's also not any fractions. So let's get rid of the fractions. Let's multiply both sides by this denominator. When you are doing this stuff, if you have a fraction, you need to get rid of the fraction. We need to get rid of the fractions. Let's keep it easy, as easy as possible. All right, y'all, those are going to get wiped out completely. So over here on the right side, let's just write 4 because that's the only thing that's left. Now remember, you have sine theta times R. Let's put the R in front because that's how we're used to seeing it. So this is going to be R sine theta. And R sine theta is Y. So this is just Y equals 4. That's it. Any questions on this? All right, so I'm going to do one of your homework problems with you. It's the one that says pi over 3. Number 4. Y'all, flip the page. Let's go to number 4 real quick, because you don't have any like this in your notes, and I'll just do it with you. All right, so for problem number 4, we need to write it in rectangular form. Okay, and it's just theta. Theta equals negative pi over 3. So the only thing that we have a theta symbol with is tangent. There's no tangent, so we're going to multiply both sides by tangent. T-A-N on both sides. Oop. All right, so multiply this by tangent. Multiply this by tangent. I'm just going to clean up the way the right side works or looks. So tangent theta, I'm going to write tangent first, equals tangent of negative pi over 3. All right, so y'all on the right side, I would totally ask you, this is fair game for a unit circle drill. This is going to be the same thing as tangent for pi over 3. It's just going to be negative. What's tangent for pi over 3? That's for 6s. When there's a 3 on top and a 3 on bottom, that's 6s. But this has a 3 in the denominator. Just root 3. We're just going to write negative root 3. So tangent of theta equals negative root 3. All right, y'all, now we're ready to substitute. Tangent of theta is exactly y over x. So now on the left side, we're going to write y over x equals negative root 3. All right, so technically, both of the variables are on the same side of the equal sign, but y'all get rid of the fractions if you can, and we can. We're going to multiply both sides by x, because it's a denominator. So y is going to equal negative root 3 times x, and then move it over. So no fractions, y'all. Our final answer is going to be positive root 3, because I moved it over, positive root 3x plus y equals 0. That's your clean answer for that. All right, let's hop back to page 9, and let's do the other way. So, down here, you've really got to have your thinking caps on, because you got to kind of analyze. It's almost like chess. You got to analyze your next move at the same time. All right, so here's the deal. Remember, we want it to equal r, or just r squared, or theta. Number 4 is pretty straightforward, because x squared plus y squared is r squared. So all we have to do is this. This is the answer. Box that in. Because that's just a straight substitution property. Number 5, not so much. We're going to have some work, little bit of work on number 5, not a lot. All right, let's substitute what y equals. Remember, y equals is r sine theta. That's 5. Now remember, your goal is to get r squared, or theta by itself. Forget theta. Y'all, theta is attached to sine. You can't separate that. But we can divide both sides by sine theta, and then we'll have r by itself. So r is going to equal 5 over sine theta. And again, y'all, anytime you can rewrite it without a fraction, you're going to do it. So we're going to use a reciprocal property for sine. We're going to write that as cosecant. So we're going to write r equals 5 cosecant theta. There we go. That's a clean answer. R is by itself. It's been converted properly. All right, number 6. Will you please do number 6 without me? Because number 6 is just like number 5. Please try to do it without me. And then after that, we'll just have 2 more examples. You're almost done, y'all. Okay. So I'm going to drop the letter x, and I'm going to write r cosine theta. Solve for r, and then of course I'm going to rewrite that using secant. So you should have got r equals 10 secant theta. Any questions on that? All right, y'all. Let's take a look at problem 7. So for problem 7, you have x and y that you got to drop in. Let's drop it in. You're going to write 3r cosine theta minus r sine theta plus 2 equals 0. Okay. All right. So remember, you want r squared, or radians by itself, or theta by itself. Theta is not going to be by itself. It's got a minus sign. It's got another trig function with it. So we want to really just try to focus on writing r by itself, which we can, but y'all, let's get rid of the 2. Move the 2 to the other side. So let's write 3r cosine theta minus r sine theta equals -2. Okay, look. You have the letter R written twice. I had to write the letter R twice. How can I rewrite this right here where I only write the letter R once? That's the key. The rest is easy. How could I write the letter R once? Yes, that's right. Factor out the R. Well, if we factor out the R, well, we can write the letter R once. Good job. Let's totally do that. All right, take that R out. Now remember, I can do that because it's like a number. There's no way you can factor out a theta because it's attached. Forget theta. But R we can factor out. So this is going to be 3 cosine theta minus sine theta equals -2. Yes, awesome. Now how do I get R by itself? I only wrote it once. We only have one R, but it's not by itself yet. How would we make this by itself? Well, if I divide by R, it'd be in a denominator over here, but I do want to divide. I'm going to divide by, yeah, that stuff stuck next to it. So R is going to equal, and then write a long fraction bar over here on the right side. So this is going to equal 3 cosine theta minus sine theta. And y'all, that's all I can do. I can't rewrite these with reciprocals because they got a minus sign in the middle of them. I can't use like one of the Pythagorean identity properties because they're not squared. That is all I can do to algebraically convert that to polar form. All right, I've got one more that I want to do with you. It's the one on page 10 that says y equals x. Number 5. Let's go to problem 5. Okay, y'all. So on problem 5, we are converting to polar form. Well, let's go ahead and write what y and x equal. So we know y is r sine theta. We know x is r cosine theta. Just put it, yep, perfect. Okay, so remember, we want to do the path of least resistance. R is not raised to an exponent, so I really want to make R by itself. So if I try to make R by itself, there's no plus or minus. I mean, I can move one thing over, but then I have more complications. I like how it looks right now. There's just something over here, something over here. So if I try to get R by itself on this side, I could divide those sides by sine. So if I hit divide, perfect. If I write divide, don't write it though. Divide by sine, I'd have cosine over sine. What's cosine over sine? It is. But look, we have tangent. So I'm going to divide both sides by cosine. Let's divide both sides by cosine. Yuck. R is not written by itself. So look, remember when you write this stuff, we usually want R by itself, but y'all, I'm not going to be able to make R by itself. If I'm not going to be able to make R by itself, I'm probably not going to be able to make R squared by itself. So I'm probably just going to focus on theta. Let's make the R's go away. How do I make the R's go away? Yeah, let's divide both sides by R. which I could have done in the beginning, but I just wanted to show you I'm stuck right now. All right, this side over here, that leaves just tangent theta. Not bad. I mean, it's okay. What's r divided by r? 1. That's a unit circle question. When do you ever put 1s for tangent? Pi over 4. Is that the only place where you get a positive 1? Yes. So that's the answer. Look. Tangent, your theta symbol is by itself. That's pi over 4. Look. Is that where the x and the y coordinate are exactly the same? Yes. That's root 2 over 2 and root 2 over 2. That satisfies that. Where else? In quadrant 3, where they're both negative, they're both still the same. That's it. That's how you work those. Y'all listen.